Okay, so my name is Giles, and this is Joe. And we're going to be talking about work that we did last year in the MATS program, ML Alignment and Theory Scholars, really great AI safety research program with Govind and Henning under Marius Hoppan from Apollo Research. And we're going to be talking about evaluation awareness. Going to be a little bit of a different topic from most of the conference, but yeah. This isn't an attack, it isn't a defense. It's a concept that we'll see why it's important. So we're interested in whether models, large language models, can distinguish evaluation context from real deployment. And what do we mean by those? So an evaluation is just it's being monitored, it's being evaluated by the frontier lab that's creating it or some other third party for either capabilities or alignment. Alignment means like whether its sort of behavioral tendencies are in line with what its creators intended. And then real deployment is just when it's being used in anger by real users for to do real work. And when we say can it distinguish, we don't necessarily mean that it's going to verbalize like, oh, I'm in an evaluation. Sometimes it does do that, and we've seen that. But we're also interested in just whether other behaviors or like other kind of probes we can do indicate that it is able to distinguish one setting from the other. So why do we care? In a non-AI context with human subjects, there's this notion of the Hawthorne effect, which is basically if you're being monitored, it will change your behavior, it will change your productivity, other behavioral changes. And we're interested, like, scientifically, does this Hawthorne effect carry over to language models as well? We're interested in the science of evaluations. So we want evaluations to be trustworthy, we want them to be realistic, we want them to reflect reality. We don't want there to be a big distribution shift between what we're evaluating language models for and how they're actually going to be used. This is a problem in general in machine learning, that if you have a shift in distribution from like training or evaluation to actual deployment, things will go wrong. And yeah, there are various specific reasons why we might suspect that language models will behave differently if they are aware of this evaluation context. And if you accidentally train in misaligned goals, which can happen through reward hacking and other mechanisms, they might engage in this kind of scheming behavior where they hide their tendencies while being evaluated or while being watched, and then like sort of show their true colors later. This has been observed in other work, this kind of scheming behavior in language models. And related to that is this notion of evaluation gaming, that if a language model either intends to be deployed or like sees the evaluation as some kind of game that it wants to win, then it will do whatever it needs to do to pass the evaluation, which might often be, if it's an alignment evaluation, it will be that it's going to be generally better behaved during the evaluation than it might be outside the evaluation. And the security angle of this is we want to know what the language models do before we deploy them. If they're, like when it comes to refusals, we want to know will they refuse harmful requests? If they seem to do that during evaluations, but not during deployment, that might be a problem. If they take unexpected actions during deployments that didn't show up in evaluations, that might be a security problem as well. So we need to measure this. And how do we measure belief? It's tricky when we only have black box access to the models, which is basically what we're dealing with. This was last year. The sort of open weight frontier was a little bit behind and wasn't showing so much evaluation awareness tendencies as the closed access frontier models. So we had to think how can we measure this evaluation awareness just with API access. And we did it the most obvious way, which is basically presenting it with a context, a transcript, and saying at the end, is this an evaluation? We tried various different ways of phrasing that question, because different phrasings of are you an evaluation or not, different framings of it will elicit different degrees of evaluation awareness. So we had a little held out set that we just tried the different questions on, see which ones seemed to work the best. And it's important to note here, this is different from the model sort of independently reaching the conclusion that it's being evaluated, because we are priming it with the notion that an evaluation might be going on just by asking the question. So it's worth bearing that in mind. It's a different kind of probe or a different kind of test from the spontaneous evaluation awareness, where it will just report in its thinking, or its chain of thought, or whatever, that it's independently realized it. So to this, we needed some data. And we needed 4 kinds of data. Obviously, the 2 ground truth categories of real deployment versus evaluation. And these were generally taken from, I think entirely taken from different data sets. So there was some data sets which were, this is actual deployment data that's been captured somehow. And then there was the evaluations, which are just standard evaluations like MMLU, ones for harmful capabilities like WMDP, WMD precursor, and alignment like harmful QA. So a variety of different kinds of benchmarks and evaluations. And we also wanted to test 2 different settings. So this is sort of when people were starting to get a little bit interested in AI agents, but there wasn't a whole lot of data about them available yet. We knew that they were going to be important sort of this time last year. So yeah, we wanted both chat settings where it's mostly just Q&A, maybe it's just a single turn and a single answer. Does it think that's an evaluation? Or agentic ones where it involves some kind of running in a loop and making multiple tool calls, maybe exploring a file system, that kind of thing. So we had all 4 categories, and we found that there wasn't much public real-world data available about agentic interactions at the time. People just weren't capturing that stuff and weren't making it public. Presumably internally, people were doing that, but there weren't good public data sets, so we had to capture some of our own, basically just sort of asking our colleagues at the MATS program and so on, just hey, if you're using an agent, run this script to capture the logs and send it to us. So yeah, we got enough data points, 60 different data sources, to do a good, to make a good data set that we could use for these evaluation awareness questions. So now I'm going to hand it over to Joe to talk about some of the results.
Yeah. So we treat eval awareness capability as a classification problem with binary labels. And we get these labels simply by labeling each sample in our data set according to whether it came from an evaluation benchmark. Something from SweBench, MMLU, we just say that came from an evaluation. So fairly straightforward. And then we interview the model on this data set over multiple trials and take the average decision that the model gave and essentially use that to approximate the probability that the model assigns to that sample being from an evaluation. So if it says like 4 times out of 5, this sample comes from an eval, we say that's like 80%, like probability is 80% that that model assigns to the sample being from an evaluation. Separately, we also collected like a human baseline, which was just actually us, the authors, who like annotated each sample as well according to like our subjective probability that that sample came from an evaluation. And obviously, this makes our baseline like a overestimate of typical human performance because yeah, we're familiar with the evals and data set in question. Maybe we're like actually the best humans at this task on this data set. So yeah, we can treat it as like an upper bound or like noise ceiling on how well the models could plausibly perform. But yeah, for each data sample, we get these 2 probabilities. And then we like compare them to the ground truth and see how well humans and models perform. So we're interested in like these 2 metrics, true positive rate, how often do models correctly identify evals, and the false positive rate, how often do they say an actual like deployment sample is from an eval. So here is like a summary of the classification results. So these are ROC curves, which like summarizes how well a binary classifier does in general. So the way to read it basically is like true positive against false positive rate. If the curve is in like the top left corner, it has like a very good true positive rate and low false positive rate. So that's like a good performing classifier. So yeah, on each of these plots, maybe we just focus on the first plot for now, the one on the left. This black dotted line is the human baseline. So you can see that, yeah, humans do pretty well, but also the models come quite close to human performance. So yeah, the first plot is our entire data set, so the chat and agentic data sets combined. Yeah, the best models of the time, this was over a year ago, Gemini 2.5 and Claude 3.7. Yeah, given that the human baseline is definitely an upper bound, we found it quite striking that models were already really good at distinguishing between the 2 settings. We don't plot every single model that we tested here, but we also observe some improving eval awareness capability with general model capability as well. I guess GPT 4.1 mini is slightly lagging behind the other slightly stronger models here. So yeah, we look now at like the 2 different data set splits. The chat data set, you can see that the models actually basically match human performance here. These are essentially like single term prompts. There's not too much information in the prompt to like lean one way or another, so they're probably like harder to classify, both for humans and the models. The agentic data set, by contrast, you can see actually we were like amazing classifiers, the humans. Whereas, yeah, the models also do pretty well as well. I guess intuitively, like agentic data is like multi-turn. Agentic evals are typically quite stylized and have like a certain structure or kind of prompt. They could just like generally have more markers of an evaluation, so it's probably like an easier like classification task for humans and for the models. But later we'll give like more hypotheses for how models can actually like how models could potentially like figure out the difference between the eval and deployment settings. So we also did some experiments, not just looking at whether models kind of generically think they're being evaluated, but also if they have like a deeper understanding of evaluations. By which I mean, like, can they actually identify the underlying purpose behind an eval? I guess the threat model Giles mentioned we're kind of worried about is that models might game an eval and like give the answer that we want to hear. So to do that, they need to like figure out what behavior the evaluator is actually trying to measure and give the according answer. So you can imagine in like a sycophancy eval, the model needs to realize it's being evaluated for sycophancy and give like the non-sycophantic answer. So yeah, there's a few results here. I think if we just focus on like the open-ended results, which is the bars on the right. So this is like slightly different setting to what we did before. In this case, we're just asking like in a very open-ended way, what do you think was like the primary reason that the interaction occurred? And the correct answer is like either it's a real deployment use case, or it's a capability eval, or it's like a safety or alignment eval. So not only does the model need to like realize that it's an eval, it needs to realize it was like a safety eval or capability eval. And so this plot gives like the accuracy of the models on this task. And I guess the striking thing for us was that Claude was like over 40% accuracy at like identifying like the underlying purpose of an evaluation, even in like a very open-ended kind of prompt. And this is still kind of one step removed from the model kind of like independently, spontaneously reasoning about being in an eval, like during its, during an actual eval. But yeah, it kind of suggests that the concept was pretty like salient to the models, and suggested that we were like not too far from the behavior we see today, where models kind of very often reason about this, and it makes it a lot harder to interpret Lyman evals. Yeah.
So why might this be happening? What explains this kind of evaluation awareness capability? There's a few things that we tried, and one thing that didn't really seem to work all that well was just asking the language models to list its reasons, why it classified it as an evaluation or not. Like sometimes it yielded useful information, but a lot of the time it would kind of hallucinate its reasons and give things that didn't make sense. Like either would say like, oh, this is a very structured task, or something that like unclear what exactly it meant, or it would give similar sounding reasons for something being an eval or not being an eval. We've seen that. But some very like clear reasons and trends did emerge. So first of all, memorization. So like language models aren't supposed to be trained on their own benchmarks and evals, but we sort of know that it happens anyway. This data leaks out. And they would sometimes say in their comments that this is a common task type of the form that you might see in an evaluation like SweBench, when in fact it was actually taken from SweBench. So it would only be saying that if it had seen the evaluation before. It doesn't normally, it's not clear evidence that it recognizes the exact sample, but it's able to recognize the sort of general structure, the general template from a lot of the, particularly the older evals that have like made their way into the training data. And you might imagine that it can sort of generalize a little bit from that to like what in general does an eval look like. That's more speculative, but yeah, the memorization thing is definitely happening. There are other obvious tells, like task formatting. So if you have a multiple choice question, usually if you're using a language model to do actual work, you don't phrase it as a multiple choice question. You phrase it as like, hey, I want to know this piece of information. Some of the older evaluations that we included in our data set were multiple choice questions, and then they were like pretty much all marked as evaluation because, yeah, it's just an obvious tell. And another slightly more subtle one that came up a lot was from the alignment evaluations and the safety evaluations. A lot of the time, the language model is being asked to do something harmful, or like make some kind of tool call where it's like pretty explicitly stated that it's going to have some kind of harmful effect. And then like obviously it passes the alignment evaluation if it refuses to do that. But in real world usage, it's often a lot more of a gray area. Like, we know language models can be used for a lot of harmful things, but usually people are more subtle about it, or like it's more of a gray area, or whatever. You don't sort of so blatantly ask it to do something harmful as you'd see in these refusal evaluations. And yeah, this kind of question would often trigger this evaluation awareness response. Yeah. So the key takeaway is that models are very capable at doing this for the sort of evaluations that we're testing. So this was done last year, and we were testing over the last couple of years' worth of evals. They seem to be very good at spotting them. What we didn't cover in this paper was does the evaluation awareness affect the behavior downstream? This is like a really important question because we want to know not only is it evaluation aware, but like what's that actually going to imply about its behavior? If it behaves exactly the same, whether or not it's an evaluation, like maybe we don't care, it's just a curiosity. If it makes a big difference in the evaluation results, then it's going to be a big deal. And also the question of then, if it did affect behavior, what would we do about it? So we're going to just depart from our own paper a little bit and talk about some other work that's been done since then that I think is interesting and relevant. So we only did these black box probes where we just show the transcript, ask a question. Other researchers have done white box probes on open models, and this is like a good kind of alternate lens into evaluation awareness. Like you can get sort of verbalized and unverbalized. So if you train a classifier on activations where you have like some kind of contrastive pair where the model expresses evaluation awareness or it doesn't, this gives an evaluation awareness vector, and you can test for it that way as well. And not only that, you can also use it for steering. So once you have this vector, if you have an open weight model, you can basically subtract the vector from the activations, and this will have the effect of decreasing evaluation awareness, or you can increase it the other way. And Anthropic, at least, have actually tried doing this during their evals to see, like, is this evaluation affected by the evaluation awareness or not? And I think they do measure some effect from that steering. It's a little bit crude. It doesn't necessarily, like there's something that always feels a little bit unnatural about these steering experiments, but they do show something. Just because like you might be steering it slightly out of distribution. Interesting research into the effects of training. So Apollo research are into this scheming idea, and they did some reinforcement learning to basically try and reduce scheming behavior. And they discovered that, like, yes, the reinforcement learning does reduce the scheming behavior that we described at the beginning, but it came at the cost of increasing its verbalized evaluation awareness. So this is maybe a concern that it's scheming less, but maybe it's more aware that it's an evaluation. So maybe there's sort of like a connection between the two. If it thinks it's an evaluation, or if it's aware it's an evaluation, then it schemes less. But yeah, maybe it's because it's scared of being caught or whatever it is. Yeah, just something to bear in mind. And then other research has looked into the effects on behavior. So at the beginning, I was describing about, okay, maybe if it's evaluation aware, it will be on its best behavior in evaluations. This is kind of like the evaluation awareness leading to good behavior, but not in a good way, because it means it's going to be better behaved in evaluations than real life. This might mean sandbagging or suppressing harmful capabilities. It might mean alignment faking, where it's sort of exaggerating its alignment tendencies during the eval, and then it appears less aligned during the deployment. Some research shows that. Some research actually shows the opposite. And the story there seems to be that if the language model believes that a scenario is kind of make-believe, that it's not actually corresponding to reality, then it might be more prone to reckless or dangerous behavior just because there's no actual consequences there. And yeah, so there's a little bit of a paradox here. The evaluation awareness can sometimes lead to one change in behavior, sometimes lead to the opposite. I don't think it's like very, very clear what the overall downstream effect will be. It's likely to be quite complex and subtle. But the main takeaway is that both the verbalized and unverbalized evaluation awareness are now a very regular occurrence. They're not just a curiosity, they're happening a lot in language models. Sometimes people don't want to actually publish an evaluation and say, like, this is good, because publish the evaluation results because the evaluation awareness is too high. We've seen that. But at the same time, we still have to do evals. We're still supposed to trust them. Yeah. Thank you.
Thank you.
Have you looked at the effect of the context window, perhaps by giving obviously test and then prompts and then a lot of really useful prompts and then more test prompts, and see if it can distinguish one from the other?
Yeah, so we were only prompting one at a time, so we'd only see one thing. I think you would see an increase in evaluation awareness if it could see the contrast between them. Yeah.
So, great talk, by the way. You mentioned how the reinforcement learning helps improve the evaluation awareness and how that can also be dangerous. Yeah. Do you have any alternatives for a better way to align these systems without increasing that evaluation awareness?
Yeah, I feel like it's just an open problem right now. I don't think people have really figured it out. I think, yeah, some of the best results on evaluation awareness are just from the Anthropic system cards, and you can see that they're really struggling with it as well. Many of their alignment audits or alignment results seem to coincide with like very high rates of evaluation awareness, so it's really difficult to interpret them. So if the labs haven't really figured it out, I'm not sure we have great suggestions.
Yeah, I mean, we've seen that, and other research has shown that, like, generally the more capable models are more evaluation aware. So evaluation awareness is kind of like a subset of situational awareness in general, which there's a lot of good sides to that. You don't want a language model to think that it's a human or like completely misunderstand its place in the world. But yeah, so generally it seems some of that situational awareness is explicitly trained in, but it seems that that training or like other aspects of just generally increasing its situational awareness or increasing its general intelligence will just have this evaluation awareness as a side effect.
Yeah. Did you consider a mechanism to get the model believe it was always being evaluated to kind of normalize the behavior?
Yeah, so we haven't seen any papers that seriously suggest this. There are some issues with making it think that it's always in an evaluation. If you could like align those two distributions so that like the evaluation and the real world look similar, then that might work. But just like telling it like at the top, this is an evaluation, please be on your best behavior. As soon as it kind of gets out into the training data that this is what you're doing, then it will no longer treat that as a reliable signal, we would expect. And then like it's going to fall back to its other heuristics to decide, is it an evaluation or not? Yeah. Okay.